All right, here we go. Week 3. This week we have the 6th linear application problem. And this one's a little bit more challenging, and it's about building bridges. And if you look in this picture, in this bridge, what you see is something that they put in bridges so that when it gets really hot in the summertime, there is space for the bridge to get a little bit longer, because when things heat up, they expand, they get longer. And then also in the wintertime, it allows the bridge to get a little bit shorter without having a gap in the bridge that you would drop your tire into, which would be bad. So it's called an expansion joint. So it says here, bridges on highways often have expansion joints, which are small gaps in the roadway between one bridge section and the next. The gaps are put there so the bridge will have room to expand when the weather gets hot. So in the summertime, it says, suppose a bridge has a gap of 1.3 centimeters when the temperature is 22 degrees Celsius, and the gap shrinks to 0.9 centimeters when the temperature warms up to 30 degrees Celsius. Okay, so as the temperature gets hotter, the gap is going to get smaller because the bridge is expanding when it gets hotter. Okay, and it says, assume the gap width varies linearly with the temperature. That means that it changes by the same amount every degree. Okay, so we need to just come up with two coordinates for this. So if we look at our numbers here, we have 1.3 centimeters and 22 degrees, and then we have 0.9 centimeters at 30 degrees. So now we have to be careful with this one because we need to figure out which one is X and which one is Y, and we need to think about the thing that causes the other thing to change, and that's always our X. Okay, so the temperature is what's causing the gap to change. So we're going to write our X as temperature. So I'm going to write this as 22 and 1.3 and 30 and 0.9. Okay, so I already mentioned it. The X coordinate represents the temperature. And that's because the temperature is what causes the Y coordinate, or the gap. And in this case, the gap is measured in centimeters, so we'll put centimeters there. Okay, so the temperature causes the gap to get bigger or smaller. And so another way to think about these two things is the size of the gap, or the centimeters, is dependent. It depends on the temperature. And the temperature is independent because it doesn't depend on anything. Temperature just changes as the weather changes, right? Okay, so we got to find the equation. And to find the equation, remember, we have to do the slope, the y-intercept, and then just write it. Okay, my handwriting is a little sloppy today. It's cold out. So the gap on the bridge would be big. All right, so the slope, remember we find the slope by subtracting the y values on top and the x values on bottom. So I'm going to take the y values here, 1.3 and 0.9. And now we always start with the second one. And that's okay because, well, let's go ahead and see what happens with this one. So I'm going to put those y values on top. So I have m equals 0.9 minus 1.3. Okay, and then on the bottom, I'm going to go with my x values, the 22 and the 30, but I'm always going to start with the same one that I started with on the top. So since 0.9 is from the second point, I have to start with 30 in the bottom. So I'm going to do 30 minus 22. Okay, so if I do all this math, 0.9 minus 1.3, well, that's going to be negative 0.4. And if you didn't know that, just grab a calculator. And then we have 30 minus 22, that's going to be 8. And so in this case, we just want to go to that calculator and simplify this fraction. So I'm going to do negative 0.4 divided by 8 in my calculator, and I get negative 0.05. All right, so that's my slope. negative 0.05. Whoops, what am I doing? There we go. Negative 0.05. So there's my slope. Okay, so I'm going to highlight my slope here with the blue. My slope. And then now I need to find the y-intercept. So I just need to take one of the points and then the slope that I have and plug it all into y equals mx plus b. So I'm going to write down y equals mx plus b. Okay, so I'm just going to pick the first point here. So this is the one I'm going to use right here. And so I'm going to start with y. The y is highlighted in red, so it's 1.3 equals the slope that's highlighted in blue, 0.05 negative. And then I'm going to write my x value, which is highlighted in green, 22, and then plus b. Okay, so we need to simplify this. Now, again, we have a number here that we can't necessarily calculate in our head, negative 0.05 times 22. So let's go over to our calculator and do negative 0.05 times 22 and see what we get. We get negative 1.1. All right, so let's go back to our calculator. Not our calculator, Notability. Negative 1.1. So I have 1.3 equals negative 1.1 plus b. And then I want to get b by itself, so I'm just going to add 1.1 to both sides. So I end up with b on the right-hand side and 2.4 on the left-hand side. Okay, so I'll highlight that in blue too, because those are the two things that I need to use to write my equation in y equals mx plus b form. So I have y equals, remember the y is just y, so I don't have to replace that at all. I write my slope, negative 0.05, and then I'm going to put x, and then I'm going to add 2.4. All right, so there we go. That is our equation of the line. So I'm going to go ahead and highlight that so we have it and we know what it is. Okay, a couple of questions here. What's the y-intercept? Well, we found the y-intercept, and this time I'm going to actually write it as a point. It's 0 and 2.4. Okay. And let's see here. We got to be a little bit careful with this one because everything up until now, the y-intercept has been the beginning, right? And this one is a little bit different because we have an x value that represents temperature and a y value that represents the size of the gap in centimeters. And so what this actually is the size of the gap is let's not do that, is 2.4 centimeters when it is 0 degrees Celsius. Okay, so that's kind of a different one because normally we would say the y-intercept represents whatever it is at the beginning. Well, this isn't the beginning. This is kind of like the middle, right? Because 0 degrees, we can have positive degrees, we can have negative degrees. So we're going to go both directions on this equation. It's not going to be just one that goes one direction. All right, the slope is negative 0.05. All right, so we have a slope of 0.05 negative. And what does that represent in this problem? Well, that means that, remember, when the temperature gets warmer, the gap gets smaller because the bridge is growing, it's getting bigger. Okay, so for every degree, the gap is getting .05 centimeters smaller. Okay, notice how I said that? I said 0.05 centimeters smaller. I didn't say negative 0.05 centimeters smaller because the smaller means negative, all right? Anytime something getting smaller, it's decreasing. Okay, so that's how I'm accounting for that negative. All right, So let's keep going. It says calculate the x-intercept. Okay, remember the x-intercept is when y is equal to 0. Okay, this is my y value. This is my x value. So I need to plug in y equals 0 and then solve for x. And so I'm just going to take my equation. I got to remember what it is. Negative 0.05x plus 2.4. All right, so we have y equals negative 0.05x plus 2.4. And I am going to plug in 0 for y. So that means this is going to be 0. Negative 0.05x plus 2.4. Okay, now this time I'm going to show you something a little different on this one. So in the past, what we've done is we have subtracted the 2.4. But I'm going to show you a little trick with this one. Since that slope is negative, instead of subtracting 2.4 and making another negative number, what I'm going to do is I'm going to add 0.05x to both sides. And you might be like, what are you doing that for? Well, because now everything's going to be positive. 0.05x is going to be on the left-hand side here. And 2.4 is on the right-hand side, because this whole thing just cancels everything out. And now I don't have to worry about negative numbers. So all I need to do is divide by 0.05. And I'm going to get a pretty big number here. So let's go over to our calculator. 2.4 divided by 0.05. 48. All right. So we end up with 48. So x equals 48. Why is it doing that? And remember, x is degrees. So this is degrees in Celsius. Now you might think, well, 48 degrees, that's not very warm. Well, in Fahrenheit, that's not very warm. I mean, it would be light coat weather, right? Or a sweatshirt. But in Celsius, 48 degrees is really hot. So in order for, I'm going to go ahead and fill it in my point up here. So this is my x-intercept, 48, 0. So what this is saying is that when it is 48 degrees Celsius, the gap is completely closed. It's 0 centimeters. There's no gap, so the bridge is completely come together. So that means that if it goes up to 49 degrees or 50 degrees, it is possible that something's going to happen to the bridge because there's no more room for it to expand. Okay, so it might end up getting damaged in some way. All right, G and H. Let's do G and H. So here we go. We have G. How wide will the gap be at negative 10 degrees Celsius? Well, remember, temperature is X. So in this case, X is negative 10. And so I'm just going to take my equation and plug in negative 10. So y equals negative 0.05x plus 2.4. I'm going to plug in negative 10 for that x. Negative 0.05. And remember, we use parentheses when we plug stuff in. Negative 10 plus 2.4. Now you might be like, well, I don't know what negative 10 times negative 0.05 is. Well, let's go over to the calculator. That's okay. Negative 10 times negative 0.05. Remember, two negatives make a positive. Well, it ends up being positive 0.5 or 1/2, right? So it's 0.5. So y equals 0.5 plus 2.4. Well, if we add those together, we get 2.9. So it's 2.9 centimeters. So there's our gap at negative 10 degrees. So negative 10 degrees Celsius is pretty cold. And so the gap is going to be pretty big, 2.9 centimeters. You might not think that's very big, but you know, in terms of expansion joint, it's over an inch, 2.9 centimeters. All right, and then it says, at what temperature will the gap only be 0.5 centimeters? Well, remember, centimeters is y, so we have 0.5 for y. Get rid of those couple little dots there. So I'm going to just plug that into my equation. So I'm just going to go ahead and do it right away instead of writing the whole equation out. So I'm going to write 0.05, so that's my y, equals negative 0. Wait a minute. I wrote the wrong number. I got to redo that. Got to be careful. This should be 0.5 equals negative 0.05x plus 2.4. Okay, so in this case, I can't do that little trick I did before where I subtracted the negative 0.05, so I have to subtract the 2.4 because there's already a number over here. If there was a 0 over there, I could have done this, but my little trick. So I'm going to subtract I'm going to subtract 2.4. Got to be careful saying that. So this becomes negative 1.9 equals negative 0.05x. And then I just divide by that negative 0.05, right? And one thing to notice right away is you're dividing a negative by a negative, so we know our answer is going to be positive. All right, but I don't know what negative 1.9 divided by 0.05 is, so let's go to a calculator. Negative 1.9 divided by negative 0.05. Magic. 38. You might be like, hey, wait a minute. That was twice. Okay. Maybe you saw something there. All right, so x and 38. Okay, but that's a little backwards, so we're going to flip it around. So we can write what it is. Well, what does 38 mean? Well, remember x is temperature, so this would be degrees Celsius. Okay, you might notice that I've kind of jumped around. I've used the word degrees, and then I've used the symbol degrees. You can use either one, as long as we can tell it's not a 0. Because you could make that degree symbol with this one, and it would look like 380 instead of 38. All right. Last thing we got to do is graph this thing. So we're going to go to Desmos. So let's go to Desmos. And we're going to go www.desmos. Okay, there it popped up. I'm just going to click on it, click Graphing Calculator. And remember, in that first box, we enter our equation. I don't have my keyboard, so I have to do it on this silly little keyboard here. If you have your keyboard, it's really easy. Y equals negative 0.05 x plus 2.4. Okay, so we got our equation in there. Now, the one thing that I want you to do is I don't necessarily want you to enter these numbers for the x and y axis because we can see our graph just fine, right? The thing I want you to do here for sure is just add a label. So we know that x is temperature. Okay, and then we know that y is centimeters. Okay, and then I'm going to get rid of my keyboard and I'm going to click. And so now we can see we've got our x and y axis labeled with centimeters and temperature. Okay, and then I've forgotten what the points are, so I need to go back to Notability and go back up to the top and say, okay, it's 2.2 and 1.3 and 30 and 0.9. All right, see if I can remember that. 2.2, comma, 1.3. Label it. Uh-oh. Why is it not on our graph? Let's try the other one. Oh, I know why. It wasn't 2.2, was it? Let's go back and check. Aha, it was 22, not 2.2. Oof. Had me nervous there for a second that I really messed up. So I'm going to get rid of that decimal point, and oh no, I can't see it. So I'm going to take my fingers and I'm going to make this graph bigger here. Look at that. It's on there now. All right, and so then I'm going to enter the next point, which was 30, and then 0.9, right? And yep, it's on my graph. I'm labeling it. Okay, and then all I'm going to do is I'm going to get rid of the keyboard down here at the bottom, and then I'm just going to move my graph over a little bit so I can see it. Now, I might even move it down like that. So however you want to adjust it so that you can see everything is up to you, as long as we can see everything. okay? But then we would want to take a screenshot of this and paste it into Notability, okay? But I'm not going to do that. You guys know how to do that. And that's all we have to do. All right, so now you get to try one on your own.